Hello, everyone. Good morning or afternoon, depending on where you are in the world. Thanks for taking the time to attend this half-hour session as a part of our virtual events week, Unlock AM Live, the digital post-printing experience. Today, we'll be discussing designing your AM part for post-printing success polymer support removal. Your presenter for today is technical trainer Francesca Baird, who has extensive experience in training both our internal team and customers on the ways that automated post-printing technologies can help revolutionize additive manufacturing. This is a live interactive webinar, and there will be an opportunity for Francesca to address questions at the end of the session through the chat feature. Additionally, this session will be recorded and made available for download afterwards. Finally, if you hear anything during the webinar that you might want to talk more in depth about, remember we are offering one-on-one coffee chats with our experts across North America and Europe all week long. If you're particularly interested in seeing our solutions in action, we have a number of time slots available for live solution experience tours this week, during which Francesca or our senior application engineer, Nick, will be guiding you through the ins and outs of one of our automated post-printing solutions in real time, including a session immediately following this event. Head over to our main event site to sign up for one of those sessions. And now that I've kicked things off, I'll hand it over to you, Francesca. Take it away.
All right, perfect. Thank you, Diana. All right. So what we're going to discuss today is why taking post-printing into account during the design phase is so important. So I'm going to talk about post-printing design considerations specific to PolyJet, FDM, and resin-based printing. And then the last topic that we're going to cover is how you can optimize your post-printing by designing fixturing. So then I'm going to wrap things up and then answer any questions that you might have. But first, we're going to get started with getting to know you guys a little bit with a polling question. So you can answer right on your screen. And let us know how long you've personally been in additive manufacturing. Are you new to additive with having 2 years or less? A bit more experience with 2 to 5 years, you a veteran with 5 to 10, or potentially 10 plus years. We'll take a moment here to let you answer. And now let's see those results. All right, so we have a pretty good distribution. A bit more newer people, which is going to be really great for you guys to get this insight. So glad to see how diverse this is. Now we'll get back to the presentation. So why think post-print during the design stage? So according to the 2019 Wohlers report, post-printing accounted for, on average, 23% of the total part cost for polymer 3D printing. Optimizing your post-printing operation and lowering this cost is key for making additive manufacturing sustainable, and it starts at the design phase. So by understanding the process your parts will go through once they come off the printer, you can make simple design tweaks to ensure your production is streamlined. So once you're struggling to finish a part, you've already wasted your time and material resources on that design iteration. By designing a part for post-printing, you're going to eliminate the numerous design iterations you go through and achieve your customer-ready part with as little changes as possible to your first design. So this will save you money from the materials wasted on failed designs, as well as the cost associated with you spending your time designing, printing, and post-printing failed geometry. So designing for post-printing boils down to 3 main ideas, and the first being fluid access. So when you're relying on chemistry to remove supports, it's important that there's as much support exposed to the fluid as possible in order for the chemistry to do its work. So this holds true when using circulating abrasive media to achieve a surface finish. In a later slide, we're going to talk about some specific design tweaks that help maximize the contact of the media to ensure you get the most uniform finish. The way that you orient your part is largely going to affect how much support is required and as well the quality of that surface fresh off the printer. And lastly, understanding how to design for additive manufacturing and the different nuances of your printer is going to be key to optimize your production. Unfortunately, this does take experience with the printer and understanding when the software may be overcompensating with support. And the more time that you spend printing and experimenting, this is going to get easier. So now we're going to have another opportunity for a polling question. So personally, what is the most troublesome part of your post-printing operation? So what causes you to redesign and rebuild your part? Is it the support removal process? Is it the initial surface finishing or potentially a surface finishing process that you're undergoing? Or are you struggling with resin removal? We'll take another quick moment here to let everybody submit their answers. All right, let's look at the results. Great. Again, so more distribution, a little bit heavier on the surface finishing side, which is great because I'm going to talk specifically about how you can design your parts to help optimize that surface finish. First, getting started with PolyJet. Post-printing for PolyJet generally involves some level of picking of support, whether with a water jet or using hand tools, or potentially on the less manual side of things, a submersion tank. So looking at either of those processes, the fluid access is key for achieving a fully clean part. Design features like dead-end channels make it extremely difficult to achieve that fluid access, so I recommend, when possible, remove dead-end channels, or if they're required for the design, consider adding a drain hole to allow maximum potential for fluid exposure. As well, when designing PolyJet builds, you have a support material matrix, and you have options for that matrix that allow for different levels of build material to fortify the strength of the support. You're going to want to use the least amount of build material in that matrix without compromising the integrity of the build. This is because the more build material used, the support structure is going to then be more difficult to remove. So lastly, here at Post-Process, we've introduced plugs into the features with large channels that get removed prior to post-printing to help speed up bulk removal without breaking the part. So if you look at the photo on your screen, you'll see a black arrow that's pointing to a build material that's inside the main build. So what that is, that's the plug. We grab pliers and take that out, and with that, all of the support material filled within that plug gets removed the same way. So this is really going to help optimizing your post-printing, reducing the amount of support that needs to be removed, and streamline your process. So now moving on to FDM. Most commonly, FDM post-printing, users are either manually removing the supports or using a submersion tank. Again, this creates that fluid access issues when post-printing. So allowing the chemistry to access as much of the support as possible is why removing those dead-end channels or adding a drain hole for detergent flow is so key. So with FDM, you have the ability to print material at a lower density to reduce your material usage. Parts printed like this are known as sparse builds. So ensuring these parts have as much fluid access as possible so they post-print quickly and are exposed to detergent for the least amount of time is extremely important for speeding up your printing production. The less time spent soaking in the detergent means you're going to reduce the amount of time that you spend waiting for your part to dry. So reducing this dry time is really going to speed up the entire production. And finally, when you're looking at the photos here, you can get the most out of each build by stacking your parts and using the height of that build envelope. So this in turn is going to simplify your post-printing because the build material from other parts acts to support the build and minimize the amount of support material needed and therefore the amount of support material that has to be removed. Talking about resin-based printing, support support removal and resin removal are two different processes that must be looked at individually. So with resin-based printing, since the supports are made of the same material as the build material, we can't use chemistry to remove them, so these parts should be designed for easy access to the support. Most importantly, this means having few internal support structures as possible. And then when it comes to resin removal, understanding the properties of each resin and what fits your application best is important because some resins are more difficult to remove than others. Higher filler resins such as Acura Bluestone or HPC, while they have great temperature resistance and strength, they're extremely difficult to clean off of a printed part. So without the proper cleaning solution, small and deep channels will be nearly impossible. So you're going to have to avoid these when you're building your design, if you haven't found the right cleaning solution, that is. So however, there are solutions designed specifically with these resins in mind. So once you've implemented this, you'll be able to regain that design freedom. When it comes to surface finish, there are steps that you can take so your part comes off the printer with the best possible finish. And as well, there are post-printing options for surface finishing to help improve that finish even further. So to get the best finish straight off the printer, you're going to want to limit, whenever possible, angles 45 degrees and over. These create very large steps, which are extremely difficult to finish, even with an additional surface finishing step. As well, your print orientation is key when it comes to surface finishing. Key surfaces which you would like to have the best surface finish should be printed perpendicular to the build plate. Parallel to the build plate, the surfaces upskin or rafters, which is what you're seeing on that hood of that little car right there, they're going to have a very rough surface finish, and it's going to be even difficult, even if you are doing a subsequent step, to achieve that surface finish. So if you look at the finish on the side of the car, which is perpendicular to the build plate, you'll see the stepping is much less drastic and would be much easier to get a smooth surface finish with a consequent step. So then in regards to designing for post-printing, introducing filleting, which is the rounding of corners, is going to strengthen your part while allowing for better media contact so your surface finish is as uniform as possible across the entire geometry. So now we're going to move on to how designing fixtures can help optimizing your post-printing by mitigating damage issues, ensuring you have full coverage of your part. You will also have more reproducibility by increasing your batch size, which is also increasing your throughput while giving you that improved process control. So specifically, I'm going to be talking about what we do here at Post-Process when it comes to resin removal. So we utilize our submerged vortex cavitation technology. This is a submersion technology that uses a vortex pumping, which you can see in that photo there, as well as cavitation from ultrasonics to help speed up the cleaning of the part. The part is going to be completely submerged in our resin removal detergent, specific to resin-based technology. And the fixture here, which we've designed, what you're seeing is the ability to stack multiple trays. So what this is doing is maximizing the capacity of your entire submersion tank. So now you don't just have that bottom rack or potentially a basket, you can layer multiple trays and take up that entire build envelope. And as well, you're going to be cleaning parts at the same time that you're cleaning your build tray. This is really going to maximize your time. And additionally, since that part is still attached to the build tray, any parts that have those really fine featured details that you might not want knocking against potentially a basket or another part, having it fixed to that tray is going to protect these fragile geometries from any damage. And as well, if you can see in that photo on your screen, there's different holes. So you can change the size of these trays to adjust to the different printers that you might have in your printing production. So to summarize all of these benefits, overall, implementing these really small changes to your part design are going to help your printing production become more sustainable by reducing material waste, as well as maximizing your energy usage and saving your time. This is going to allow you to have more successful builds that require less time to post-print in turn increasing your efficiency and allowing you to grow your throughput. So in combination, these benefits will streamline your production while saving you money and time. I'll pass it back to Diana.
Great. Thanks, Francesca. I'm sure, speaking on behalf of everyone, I'm going to say we appreciate your insight into how impactful part design can be for post-printing. We're going to get to Q&A in a second. I know there's some questions already queued up. I'm going to remind everyone not to miss your chance to speak one-on-one with an expert from post-process in a coffee chat in case we don't have time to address all the questions. Additionally, we'll be sending an email when this week is concluded with recordings of all the sessions and a survey so you can give us your valuable feedback on the event. Now we're going to transition to Q&A. So let's take a look at questions from the audience.
Okay, great. And additionally, while these questions come in, I just wanted everybody to know at 9 o'clock, I will be touring our lab with our PolyJet and FDM support removal solutions. So if you do want to tune into that, you have 30 minutes after this free. We're also going to add in the link to that event so you can sign up there. Okay. So our first question here is regarding PolyJet support removal. So how we do PolyJet support removal in-house. So that goes to that plug method and why bulk removal is so important. So we have a submersion tank, that same technology that you saw for our resin-based, where it's the ultrasonic, that vortex motion with heat control. That's also going to be how we adjust PolyJet support removal. So we do recommend, depending on what that geometry looks like, you perform that bulk removal and you make sure that the fluid has as much access as possible, but then it will be entered into one of our submersion tanks. Thank you for that question. I have a question here about the media I was talking about for support removal. So the media that we use is not for support removal, that was for surface finish. We have different sizes of abrasive media and different medias depending on what finish you're looking to achieve. So the media really acts as tiny little bits of sandpaper and it circulates throughout the chamber, and the part will go through the media and it touches all of the different surfaces, giving you that uniform finish. So that's why those organic geometries that have those rounded edges are really important, so the media can have as much contact to the part as possible. I have another question here regarding what is the narrowest channel that our SLA detergent can get into for resin removal. So to date, and we've done numerous field testing with thousands of trays as well, we process parts in-house. We haven't seen a channel that our detergent hasn't been able to penetrate. The one caveat is that it will extend your cycle time just a bit while the detergent works its way through that channel, but we've had really great success with narrow channels and even dead-end channels with our SLA detergent. Okay, I have another question here about larger parts. So many of our customers print prototypes for the automotive industry, and they're constantly looking for faster ways to deliver their design. So that's actually really great. We've hosted an awesome webinar at, it's on our website. You can go tune in. The Toro company, which does lawnmowers, if you're not familiar. So they were building these larger tank-like parts, so similar to what an automotive customer would be doing. And by introducing, they were using FDM, which I would be assuming in the automotive industry, that's what you would be looking to do too. So we have a spray solution that really speeds up these cycle times. And as I was talking about with those sparse parts and the drying out of those sparse parts, with the spray technology, you're not being completely submerged in the detergent. So we really speed up how quickly not only the process happens, but how quickly that drying happens. Thank you for your question. So a follow-up question to that are what are the advantages of a spray system for removing the supports? So the spray system, since you're not completely submerged in the detergent, one, you're going to have much quicker dry time. Two, it's not a high pressure system. Still, we're letting chemistry do the bulk of the work. It's more dousing the part in the chemistry, but that added bit of mechanical energy of the pressure from the spray is going to be removing of the supports as they're weakened, so you're really going to be speeding up your cycle time. We on average, our cycle times are between 30 minutes to 2 hours for the more complex geometries in our spray systems. And those are for SDM once again. I have a question here about consistency with cleaning your machine for production parts. So using one of our solutions, which are automated and run by our software, you're really going to get unparalleled consistency. Not only are you batching your parts, so all of the parts that go into the same batch are going to be experiencing the same energy sources, but as well, our software is monitoring those energy sources throughout the entire cycle, every single cycle. So you're never going to have to worry about setting the same parameters or not having a machine that's being monitored constantly, or you having to go and monitor that machine. So that software is going to allow you to reproduce the same results over and over and over, from having numerous parts in a batch and then having the same results from batch to batch. Thank you for your question. So what happens to excess supports that are washed off? So for all of our systems, you use our detergent until it's been saturated. So in our submersion systems, the support just circulates within the detergent. In our spray systems, it's the same thing. Depending on what solution you end up going with, we will help you determine how often that needs to be swapped out. But the support is taken into the machine and then disposed of after your solution has reached saturation. Thank you for your question. Okay, so I have a question. How does the system know to remove only support? So that's a really great question, and I touched on it a little bit when we were talking about resin removal. So when the build material and the support material are the same, so for instance, resin-based or Altum or your Peak builds, we're not going to be able to remove those supports, because the way that we go about support removal is by using a chemistry that specifically attacks the material that is different from the build material. So understanding the material properties and using a detergent that's only going to address the support, that's how we preserve the integrity of the build material. Thank you. So I have a question here about our surface finishing media and the chemicals we use. So the media and the chemicals are two different things. The surface finish media, we have different media and what they're made of depending on what your application is and what material you're using. So some are ceramic based, and then we have some more porcelain media to give you more of a better shine and aesthetic feel. We can use those in combination. You can have a two-step finish. And then the chemicals that we use, so we do have a detergent that goes in there. It's not specific to the technology. So you can use any technology in there, be it metals, polymers. They can all go into the same batch. The only issue would be how those parts interact with each other. So you wouldn't want fine featured parts in with a more robust metal part, because those might interact negatively. But the detergent there is really to act as a lubricant. So once again, we're achieving that uniform finish across the entire part. And then as well, the media, It will break down as it is abrading that part, and some of the part is going to break down as well, so that detergent is also going to wash away any of that broken down material. Thank you for your question.
Okay, let's see if we have any last minute questions coming in before we let Francesca go, so she can, as we mentioned, run a live tour going on at 9 a.m. Eastern in just a few minutes. So, okay, hopefully we answered all your questions. If not, again, in the chat, you saw the opportunity to sign up for a coffee chat. Thank you so much, Francesca. Thank you to our audience. Please reach out to us with any questions at all. We appreciate you attending. We hope to see you at another event this week, and everyone have a great day.
Great. Thanks, guys. I'll see you again soon.